Now, what I'm going to do to start this off is just make a drawing of what that would look like going from 0 to 2. And I'm going to let this be 2, and this is 0. And I want to separate this into 8 partitions. So I'm going to have 1/4, 1/2, 3/4, then 5/4, 3/2, and 7/4. And just like what we did on the driving project, I'm going to construct I'm going to construct rectangles from this. And I think the last problem we did was the right-hand partitions. Is that right? Okay. So on that one, what we did is we said, okay, this is going to be at 1/4. So I'm going to use the height at 1/4 because 1/4 is to the right of 0. Is there a question about that? My next rectangle, I'm going from 1/4 to 1/2, so 1/2 is to the right of 1/4. So I'm going there with it. Then 3/4. One. 5/4. 3/2. 7/4. And then finally 2. So those are my rectangles. And I'm going to take the areas of those rectangles, and from the areas of those rectangles, I'm going to sum them up and approximate the area beneath the curve. Now, is that going to be the exact area beneath the curve? No. Will it be greater than the actual area, or will it be less than the actual area? It's going to be a little bit greater. So this is what we're going to call an over approximation. I know, that's a creative name there. Now, what is the width of each one of these partitions? 1/4. So I can take my width because it's a constant width. Now, when I teach this, I let all my partitions be of equal width. If you look through some books, you're going to see where they don't let each partition be an equal width. I just don't choose to. So, I'm going to have f of 1/4 plus f of 1/2 plus, and then I'm going to go all the way down to f of 7/4 plus f of 2. And those are going to be my values that I'm going to sum up here. Now, how do I figure out what f of 1/4 is? Plug it in, right? 1/4 squared is 1/16. So what's 1 plus 1/16? 17/16. All right, now I go to 1/2. 1/2 squared is plus 1 is 5/4. Now, I'm going to put all of these numbers in, even though I didn't write them all in the first step. What's f of 3/4? 9/16, right? And what's 9/16 plus 1?
27/16.
I think it's 25.
Yeah.
25 over 16. All right, now we're to f of 1. That's a tough one. 2. All right, 5/4 is 25/16. What's 25/16 plus 16/16? All right, 3/2, 9/4. What's 9/4 plus 4/4? 13/4. All right, 7/4, 49 over 16 plus 16 over 16 is 65/16. And then finally we get to 2. F of 2 is 5. Okay, so let's start cleaning up what we can here. We've got 1/4 of, all right, 17 plus 25 plus 41 plus 65. $148, is that right? I've got 148 over 16. All right, now let's take care of our fourths. That's 5/4 and 13/4, which would be, and then 2 and 5 is 7. Okay, let's simplify here what we can. 148 over 16. 37/4 plus 18/4 plus 28/4. So I've got 28 plus 18 plus 37. 16 and 7 is 23. 2, 4, 5, 83. So I get 83 over 16 as being my sum here, I think. That's right. Okay, good. Now, again, that is an approximation. It's an over-approximation. Now, I'm going to do the same problem, but I'm going to use left-hand approximations with 8 of them. That's not on the board. I want to be on the board here. Or on the screen. 8 left-hand. All right, now, this one would start with f of 0, right? And it would end with f of 7/4. I'm doing left-hand approximation, so now I'm using, that's good. I should have done this. I'm sorry about that, Ryan. You've come to expect perfection out of me, and then I just let you down. So now I'm here, but now this time I'm using left-hand approximations, so it gives me okay. So I use my f of 0 this time for my first one, and I don't use f of 2. F of 2 would be out here, and I'm not using that one. So to do my left-hand partitions right here without going through all of this arithmetic again, what I can do is I can subtract 5 and add 1. Does that make sense? So subtracting 5 and adding 1 is the same thing as subtracting 4. Right? Okay. So what is 83/16 minus, no, hold up, I'm getting ahead of myself. That's before I distribute the 4 in here. So $37 plus 18 plus 20. What did I say this was 83/4?
Yeah.
Okay, so we want 83/4, and I need to subtract from that 16/4.
It was 83/16.
I know after I multiplied this 4 in,
Oh.
but the sum was 83/4. So take away 16/4 is 67/4, which would become 67 over 16. Yeah, I should have done that to begin with. 67/16, is that right?
Mm-hmm.
Okay, so 67/16 is my left-hand approximation. So what do I know about my area? My area is somewhere between 67/16 and 83/16. How could I come up with a better approximation than that? Say that again? Take the average of the two. Yeah, in this case that would work. It won't always work. In this case it would work. But I'm looking at something else here, and you answered the question correctly. I just didn't ask the right question. So let me rephrase what I was trying to ask. Would it make sense that I could get a better approximation here if I increase the number of rectangles in here?
Yes.
Because if I increase the number of rectangles in here, these gaps, let's just take this one for example. Let's say I double the number of rectangles. Well, if I double the number of rectangles, then the amount of white gaps at the top, or the area of the white gaps at the top, would decrease, right? There's less of a white gap there. So we should get a better approximation of the area. So this would be if I had 16 partitions. Well, guess what I could do from there?
32.
I could go 32. I could go 64. I could go 2048. Ooh, all right. But if I increase the partitions, what I can do is get a closer approximation to my area. That's where we're ultimately going to go with it, but we're not quite there yet. And we looked at that the other day when we talked about the problem with the beams on it, right? The more squares we had in there, the more squares we included in the beam problem, the closer we could get to the actual area of that beam. The more partitions we have, the closer we can get to the area beneath the curve. So, let's look at solving this problem here. And I'm going to use right-hand partitions. But let's say I want to do it with 64 right-hand partitions. Now, what do I not want to do here? What?
All the additions.
I don't want to do all that work, do I? I don't want to, this took a while just for me to do 8. And now I'm talking about increasing it up to 64 partitions. And then plus, if we get divided into 64 partitions, our denominators get really large, and then we're squaring them. So, let's see how, that's beautiful. Let's see how we can make this work. Well, what are we doing? We're summing up a lot of numbers, right? So what might we think about this being here? A summation. That is correct. Who has my towel or my shirt or whatever? Here it is. Never mind. Okay. So, what would be the width of each partition if I had 64 partitions up here? 1/32. The width of each partition on the closed interval from A to B would be B minus A over N. So in this case, what did we say? We said we were going from 0 to 2, right? And we were doing 64 partitions. So we had 2 minus 0, which is 2, divided by 64, which is, as Josiah said, 1/32. So the width of each one of my partitions is going to be B minus A over N. All right, now, what is the height of my first partition? It's f of what? 1/32, yeah. My first partition is going to be f of 1 over 32. My second partition, and I'm not going to do any simplifying here, and I think you'll see why, is f of 2 over 32. F of 3 over 32. Plus f of, all the way out to plus f of, and what would be my final partition? 64 over 32. Are we okay through this? There's a lot going on here. This is going to take some thinking here. Now, what this would be right here is this would be 1/32 squared plus 1. Plus 2/32 squared plus 1. Plus 3/32 squared plus 1. Plus 64/32 squared plus 1. How are we feeling about this? Okay. Now, let's talk about how we could write this out as a summation. But to do this, we need to figure out how we would figure out some arbitrary partition. So what would be the ith partition? What was the first partition?
1 over 32.
You're on the right track. Plus 1, right? Squared plus 1. So how could I figure out my ith partition? I over 32 squared plus 1. And that would be from I equaled 1 to n. No, not to n. I know my actual number. What is my number of partitions here? 64. Is there any question about that? Now, I need to get it into thinking along the lines of my shortcuts. So, what I'm going to do is I'm going to turn this into two. I'm going to turn this into two summations. My first summation is going to be I equals 1 to 64 of I squared over 32 squared plus I equals 1 to 64 of 1.
Why are we squared 32?
Hold up just a second. No, I'm not there yet. I'm sorry. I'm off by just a little bit. Give me a second. Okay. I jumped ahead a little bit. I need to write this out as being 64. I equals 1 to, it's going to be I squared over 32 squared plus 32 squared over 32 squared. Now, what is one over, or what is 32 squared, I should say? So, this becomes 1 over, what'd you say? 1024 times the sum of, oh, that's beautiful. Are we okay? Yes. I factored out a 1 over 32 squared from everything. let's see what we can reduce right here. 6, that's gonna become 3, that's gonna become 32. 3 into is that all it reduces? 65, 11, 1, 2, 3, 3, 9, 12. Okay, never mind, it goes into this. 3 into 29, that's gonna be 43. Okay, so, what is 32 times 65 plus times 43? Could be pretty big. 89,000 what?
440.
440? Okay, plus, what's 1024 times 64?
65,563.
65,000,
536.
36, okay. And you add those two together. $154,000. 976. Okay. Now, what we just summed up was all of the heights. So we haven't summed up all the areas. This is the sum of all of the heights. So to sum up the areas, we would need to multiply by the width of each one of our partitions. And what did we say the width of each partition was going to be? Say that again. 1 over 32, right? Okay, so what's 1,024 times 32? 32,768. Now, approximately, what is the math when we do 154,976 divided by 32,768? Say that again? 4.729. What was 67 divided by 16? 4.1814. What was 83 divided by 16? 5.1875. So we see, yes, this right here falls in between those two right there. Now, Donovan, as you said, it is pretty close to the average of those two. But still, what we wanted to do here, instead of doing the average, is we wanted to see, okay, now I've got, and that's an over, I'm sorry, we did right hand, yeah, that's an over approximation, so it's still a little bit greater than what the actual answer could be. But I could go back through and do a left-hand approximation on each one of those, and it would be probably 4.5 something. And again, we're closing in on the actual area here to come up with the answer.
Where did you get the 5.187?
That's 83 divided by 16. So that's some pretty good stuff right there. Don't really have time to do another one of these problems
I think that's good.
that we don't have time to do another problem.
Not that it's good that we don't have time to do another one, just like,
Something. I agree.
like I think that's good.
That's good. We don't need to go any further with this. Nah, we gotta see where this all goes in, cause it's all gonna play in together, and it's gonna be like, wow, this was worth me taking this class. Mhm.
So you,
Okay, I think we can turn this video off.